Outliers are unusual values in your data set. So there are techniques for being able to identify outliers. It's not a subjective assessment. There actually is criteria. Before we get into it too much, as it says on the syllabus, the homework for that is associated with outliers I've modified. As it's listed on the syllabus, the homework is page 135, number 14. It's the only question really about outliers. For question 14, there are parts A through D. Do these as it is in the book. But what I'm going to do is add on to it. We're going to have sections E, F, and G. Calculate sample mean and sample standard deviation. Determine the upper limit and lower limit using those. And then identify any outliers using these limits. So we're about to get into it. There are two ways of identifying outliers. One is using a box whisker plot. That's what sections A through D deal with. And the other way is using the mean and sample standard deviation, which is what E through G is. The example we're going to be using, here's the data. And I like to think of this one as making this data as maybe depth of snow in a particular mountain range. There are a bunch of measurement sites at different locations. And these are centimeters of snow. So the first way of doing it, I guess in the same direction as the question in the book, number 14, let's do it using the box whisker plot. So if we're going to use a box whisker plot, then we're going to need to sort the data, which I have done here. And we need to quickly find the quarter points and the median. Here is our 5-number summary that we can make our box whisker plots. I'm going to make a horizontal box whisker. Here's my axis. So here's the box whisker plot. Now what we're going to need is the interquartile range. Right, which is going to be 47 minus 22. So our interquartile range turns out to be 25. Now, the definition of outlier for a box whisker plot. We have what are sometimes called fences or limits, right, that are set so that if there's any data outside of the limits, that data would be identified as an outlier. And the kind of definition, I suppose, we have the upper limit is going to be the third quartile plus 1.5 times the IQR. I could write this out in formula form, and it would look something like that. And so, oops, that would be upper limit. So this turns out to be 84.5, centimeters of snow. 84.5 is approximately here, right? That's our upper limit. Now we can do the exact same thing for the lower limit. That's going to be first quartile minus 1.5 IQR. So that's going to be 22. And this turns out to be negative 15.5. So we need to go, here's negative 10. Negative 15 is actually right around here. So here's going to be our lower limit. and over here is the upper limit. Now, our minimum isn't over the fence. So we don't have any outliers on this end, but you can actually see our maximum is over the fence on this side. And we can look at our original data. Is the maximum the only one? Yes, because 54 is less than 84.5, so that's not an outlier, but the 105 is. So we can say 105 is an outlier because 105 is greater than 84.5. Now, here comes, now that we've identified, an outlier, the question is, well, what do we do? Right? Do we get rid of it? Well, no, not necessarily. When we identify an outlier, it's to investigate, because it might be a mismeasurement. If this is depth of snow, perhaps the measuring device, the sensor, whatever is out there, might have malfunctioned, right? Because it's just so unusual, right? This data set, or maybe it's a legitimate measurement. It's just an unusual measurement. So you don't necessarily get rid of it. You just investigate it and say, well, is this possible? Well, I suppose it's possible. Maybe this was set in some valley that got a particular concentration of snow. It's possible that we could have this kind of snow depth. Now, if we had a measurement of -10 or -20, can we have a negative amount of snow? No, that's impossible. So if for some reason we had a data point like that, we could identify it and go, wait, no, that's not even possible. So that should be thrown out. That must have been a malfunction of something or a mismeasurement. So that's how to identify outliers using box whisker plot. Now, there's another way of finding outliers using the mean and standard deviation. To use that method, of course, we need the mean and standard deviation. So we come over to our calculator. We can enter our data into L1, which you can see I already have done. We can go to Stat and Calc, the Calc menu, 1var stats. We can do the one variable statistics for L1, and here we have our mean, sample standard deviation, and regular standard deviation. This we'll assume is a sample, so we'll use the sample standard deviation. So mean is 36.69. Sample standard deviation is 22.34. If we were to look at this distribution, and this is very much like looking at the box whisker plot, but we'd use a histogram. So we can set up our plot 1, which is a histogram, L1, that looks good. And we have the window settings, which I've already set. And here we have our nice histogram. We can hit trace, and we can see that it goes from 2 to 12. We have a fairly symmetric histogram. You'll actually notice that this only goes up to 62. And this is something you have to be careful about creating histograms, especially with the calculator. We're not seeing all of the data because we know from over here that there's a 105. So we can come back into here, and let's make this maybe going up to 115. Yep, and there we can see there's this lone data point that seems quite removed from the rest of the data. So what we can do is figure out the upper and the lower limits. So the upper limit, instead of using quartiles in a quartile range, we're going to go from the mean, and we're going to go 3 standard deviations, or sample standard deviations away. I meant to show you that in symbolic form, right? So that's really your formula. And in this case, it'll look like that. And this upper limit turns out to be 103.71. And of course, the lower limit is going to be minus the 3 standard deviations. And when we plug those numbers in, we end up with negative 30.58. So if we come over here into this histogram and look at where these upper and lower limits are, what I'm going to do is maybe get a new page and draw this histogram. Here's the histogram, and I've copied down the mean, upper limit, and lower limit. So, mean is somewhere in here. Our lower limit is negative 30 or so. So, there's our lower limit. Our upper limit is 103.7 or so. So there's our upper limit. And you can see it splits, this box. If we look back at the original data, we have that 105, which is, of course, over the fence. So we still have the same conclusion. 105 is an outlier because 105 is greater than 103.71, so it's over the fence. It's the only one that's over the fence, so it's the only outlier.